So this is showing essentially the same as the last example, although this one tends to be a little bit easier to use to draw your own graphs with. So if you're going to use an app to draw some of your own embedded functions, this one might be a little bit easier to use. So you can change the values in here to whatever functions you want. So I've changed the inside function to log, the outside function to sine x. Okay, so I've got my log x function in green. Okay, I'm just going to move that up. Okay, so I've got my sine x function in yellow here. Okay, and then my embedded function is going to be this sine log x. Okay, and I'm just going to take away these graphs here. And you can see that it's going to kind of go bounce back and forth as we get close to 0. Because as log gets closer to 0, it's going to go to negative infinity. So it's going to go through, input a whole bunch of angles through the sine function, which is going to make it go up and down through its positive and negative sine values close to 0. So there's an infinite number of solutions in here. As the log function, as x gets bigger, the log function slows down the growth of the x. So it's going to then go through the x values much more slowly. So if I zoom out, you can see that it starts hitting the zeros a little bit more. Okay, it's going to go down and up, but it does it very slowly because of the way the log function is going to slow down the growth of x. Okay, so there is our embedded function. This is a good app to use if you want to see how the individual pieces affect the combined function. You can see that the domain of the blue function, which is our composite function, is affected by the domain of the original inside function. Okay, because that affects the graph. The domain of the outside function actually doesn't have any effect because the domain of this outside function g is all real numbers. So there's no restriction here. The restriction comes from the log x.